Hello everybody, this is Miss Cavani from Saxe High School. Mr. Askins and Mrs. Sawyer will also be using this video. Today we're going to talk about Avogadro's principle, which is basically using the ideal gas law at standard temperature and pressure. So there is another constant that we can use, and this constant is that at a given at standard temperature and pressure, volume in moles is given, we can use that 1 mole of any gas will occupy 22.4 liters. So if either the volume or the moles of a gas is given, we can always determine the other using one-step conversion, which again, 1 mole is equal to 22.4 liters. Okay, so if your given is moles, you can just use that 1 mole is going to take up 22.4 liters. And vice versa, if you're given the liters, you can put liters on the bottom per the diagonal rule, and that is equal to 1 mole. So how does this work in a problem? Well, again, you have to remember that this has to be at STP. Okay, if this is not at STP, you cannot use that 1 mole of a gas will take up 22.4 liters. Okay, if it's not at STP, you're going to have to use the ideal gas law, which is PV equals nRT. But if it is at standard temperature and pressure, you can use this to convert from moles to liters or from liters to moles. Okay, so here they're asking how many moles of oxygen gas are contained in 135 liters of oxygen at standard temperature and pressure. So because they say standard temperature and pressure, I'm allowed to use this. Okay, so I'm gonna, as always, start with my given. So my given is 135 liters of oxygen. Okay, we're gonna set up our train tracks. Okay, and because my unit here is liters, I'm going to use this constant so I can convert to moles. That's what they want. My unknown is moles. Okay, so we're going to put 22.4 liters on the bottom, and that's equivalent to 1 mole of gas. In this case, our gas is oxygen. So mathematically, all you're going to have to do is 135 times 1 divided by 22.4. And that answer is 6.03 moles of oxygen. Okay. The next one, it's saying how much space, meaning volume, which is liters here, will 5 moles of hydrogen occupy at standard temperature and pressure. So again, because it's at STP, I can use that 22.4 liters of a gas will occupy 1 mole. So I'm going to start with my given, which is 5 moles of hydrogen. Okay, we're going to set up our train track. And because I have moles as my given, I'm going to put 1 mole down here. And 1 mole of gas occupies 22.4 liters. So in this case, all we'd have to do is 5 times 22.4 divided by 1, obviously, which is just 5 times 22.4. And that answer will be 112 liters of hydrogen. Okay, so in this case, we were going from liters to moles, so we divided by 22.4. Here, we're going from moles to liters, so we multiply by 22.4. Okay, we got 2 more. A sample of nitrogen has 1.7 moles and occupies 38.1 liters at standard temperature and pressure. What volume will it occupy with 2.6 moles? Okay, well, this is basically a proportion, but since we have the moles that we want to that we know, we can find out what the volume is. So I'm just going to start with that one. We have 2.6 moles of nitrogen. Set up your train track. I know that since I'm in moles here, I need to be in moles down here. So 1 mole of gas will occupy 22.4 liters if and only if you're at STP. And this will be 58.2 liters of nitrogen. Okay. Last one. How many moles of gas are in a human's lungs if they are measured to contain 5.78 liters of gas? Okay, so again, we're going from liters to moles. Okay, so I have 5.78 liters. Okay, I'm in liters right now, so I need to cancel out liters on the bottom. So that's 22.4 liters of gas at the bottom for every 1 mole. Okay, now something we have to mention here is that this is assuming that we're at STP. That problem should have said this. Remember, you can only use this conversion if you're at STP. So mathematically, you would do 5.78 divided by 22.4, and that is 0.258 moles of gas. Okay, you guys are going to try out a few on your own, but these are the Avogadro's principle. Again, this says that if you are at standard and temperature and pressure, you can use this conversion. That 1 mole of a gas will occupy 22.4 liters. And again, this is a one-step conversion. It's either going to be moles to liters or liters to moles. All right, hope this helps.